Hi, everybody. Thanks for joining the talk. My name is Felipe Wisi. I'm the CEO and co-founder of Unikraft. And today I'm going to be talking to you about how to debloat the cloud with Unikraft. So let's start with a very simple scenario. Imagine you want to deploy an application to the cloud. We can take a web server such as Nginx, for instance. And then if we kind of have a look at the binary, it's only 1.1 megabytes. So that seems pretty good. Let's get it on the cloud. And one way I can do that really easily is maybe I go to the AWS marketplace to fetch me some AMIs. For instance, here's a WordPress plus Nginx one on Debian by Bitnami, or I can get one directly from Nginx, this time on Ubuntu, and there's some others I can use as well. So the problem number one is bloat. As I mentioned before, the original binary is 1.1 megs. And the problem is that to run it, you put it on Debian and you end up with a 1 gigabyte large image. It's not any better with Ubuntu, where you end up with 2 gigabyte image. The second problem is layering. What you'd like is something like this. You want your application to run as close to the hardware as possible. Of course, you're on the cloud, so you need a hypervisor to isolate the different tenants, or maybe the different microservices within the same tenant. So that means that you're going to have a virtual machine, which means there's going to be a guest operating system, there's going to be user space, and for good measure, let's throw in a container runtime for management, and then your application on top. And by the time your application wants to talk to the server in the outside world, it has to get through all of these layers, which is quite inefficient. The third problem is that your application and your virtual machine on the cloud is always on. So when you first deploy it, it's just idle, but it's still on, it's still consuming cycles. And then it doesn't really do anything useful for you until the first request comes, then it comes active, but then it goes idle and then the cycle repeats. But you're paying for the service the whole time. So the problem is that you're basically running an entire cafe where the only thing you want to do is run an espresso. You know what your application is. You don't need such a massive image to run it. So is there a better way? And the answer is that you should really specialize, since you know what the target application is. And in the realm of virtual machines, specialization means what's called unikernels. So if you've never heard the term unikernels, very quickly, in a nutshell, a unikernel is a specialized image, as I mentioned. So normally when you want to put together a web server on a regular distribution, you have third-party libraries, OS services, the kernel, and you have lots of components there. Probably the web server only needs a few of those components to run, the ones that I've colored in here. So if there could be some magic way to just take those and build it into a purpose-built image just for the web server, that would be what a unikernel does. The problem with doing this is that it requires lots of development time to have to do it by hand each time for each application. So we built Unikraft as a toolkit to easily build, deploy, and monitor unikernels. So the Unikraft model has a few principles. It's a library operating system, so it's modular. It's a unikernel development kit, as I mentioned. There's very well-defined APIs so that you can plug and play different modules all the way up the stack. We've targeted POSIX compatibility as much as possible so that you can run a modified software. So you don't need to take off-the-shelf applications and port them to Unikraft. And we're also targeting ecosystem integration in order to minimize deployment disruption. And I'll say a few words about that later. Okay, so just to be clear, what I mean by POSIX compatibility, this is a very simple diagram, purposely simple. So if normally you have the application, you have the POSIX layer and Linux underneath, here's what we're doing is replacing Linux underneath with Unikraft and keeping the POSIX layer in place so that the application thing's essentially still running on Linux. Okay, so here's an architecture diagram for Unikraft. The application at the top It plugs into libc, which at the time of this presentation, it's either muscle or newlib. And underneath, there's a bunch of libraries that implement POSIX compatibility, essentially. Under that is the core of Unikraft with these well-defined APIs marked in black to do with different subsystems, whether it's scheduling or networking, memory allocators, and you can really easily plug and play those. Under that, you have support for the different virtualized platforms and hardware CPUs. And if you put all of this together, what we did is build an Nginx Unikraft image. We deployed it on Amazon AWS. And what we did is we did a little script that basically, when it boots up, it calculates how long it took to boot up and how much memory the image is consuming. And then when you point to that IP address, just in time, this thing boots and prints these stats. So you can see that it's booting pretty quickly in a few milliseconds. It consumes very little memory, just a few megabytes. So this is just to give you a little taste of the power of what a unikernel can do. So unikernels are supposed to have quite good performance, so we wanted to test the performance of Unikraft against a number of other operating systems. One of the typical KPIs in this case is throughput. So we took an Nginx web server and we started using WRK against it, trying to measure requests per second on a single CPU. So you can see at the very top is Unikraft running on KVM. And one of the comparison points was against other unikernel projects. You have OSV underneath, Lupine, then Linux bare metal, Docker, Rump, which is an older unikernel project based on BSD. Then you have Linux in the virtual machine, and then Lupine, Linux VM, and Mirage, which is an OCaml based unikernel. And if you do all of that, you end up with Unikraft at the top, clocking in at about 300,000 requests per second on a single CPU. In another test, we measured latency. In one of the previous diagrams, I was showing that Unikraft has a much more direct path to the network stack and everything else underneath. So it's perhaps no surprise that it has lower latency. This is a comparison against Linux for different request sizes in which the latency of Unikraft is roughly about half or so that of Linux. Another thing we measured is memory usage. How much is the entire stack consuming, the entire unikernel when it's running? So we have Unikraft on the left, and again comparing against containers, Rump, Hermitax is another unikernel, Lupine, OSV, and Linux. And then you can see the values. Anything Linux is at least in the tens of megabytes. We try this for several applications. Nginx is in green, Redis in red, and SQLite in blue. And Unikraft always consumes significantly less, so just a couple of megs. And then on the right-hand side, disk space, the Unikraft images are pretty small. In this case, for Nginx, for instance, is 1.3 megs. Most of that consumed by the actual application. In comparison, a Docker Nginx image is about 43 megs. So Unikraft boot times, you saw in one of the earlier slides that Unikraft boots relatively quickly. For this, we've used a number of different VMMs. QEMU first on the first bar, then QEMU with one virtual NIC, QEMU using the micro VM flag, which boots faster, then Solo 5, and finally Amazon's Firecracker. And as you can see, most of the bars are purple. This is the time that the VMM takes to boot, and the yellow part is the part that Unikraft takes to boot. And in the fastest case, with Firecracker, you can boot Unikraft images in a few milliseconds, 3 in this case. Okay, platform support now. So Unikraft started 3-4 years ago with very rudimentary support. So we were only supporting x86. We could only run on the Zen hypervisor, and we had a very crude libc called node-libc. Since then, we've added KVM, we added newlib, which is a libc from the embedded world. We, a few years back, started adding ARM support, so there's a lot of people working on ARM64. And more recently, we added support for the muscle libc, which is a glibc compatible libc. And also from the community, there's people working on Hyper-V support and the RISC-V architecture. In terms of framework integration, we're putting a lot of effort to making sure that Unikraft is not difficult to use or deploy. So the first part of that is on the development side, we've done a VS Code plugin. So here's a relatively brief video of that. So if you were to install the Unikraft plugin, here we're going to show how we create a new, let's say, Hello World project. You can see on the left-hand side that there's a U for Unikraft special symbol. Here we're going to create just a simple C-based project. First, we're gonna initialize an application using a template. Okay, that is set up, so we can see the output console at the bottom. Okay, so that sets up the basic project with the basic C files. Okay, now that that's there, the next thing is we're gonna configure it. This is going to happen rather quickly, but normally in the configure step, you could even go and choose which libraries you're going to use and customize them. I mentioned Unikraft is fully modular. Okay, so that's it. And now we're building it. It's done. It's generated the images. And so we can now run the project. We're choosing KVM and x86 64. And there it is. And it says, hello world. It's already ran. And you can see the source at the top. So now we're going to change hello to by world. We're going to look at the output again. We're going to go ahead and run it again on KVM, and now you should be able to see by world instead. So it's relatively painless to use Unikraft and build images on VS Code. Underneath all of that, there's a tool called Craft that we developed, which is the tool that we use to make it simple to actually build this stuff. This is what VS Code is using underneath. I'm not really going to cover this a lot, but basically if you're a developer, you can download Craft and it'll help you build Unikraft images. So the one-liner command for Craft, the easiest way to use it is a command called Craft up, and then you can choose the application you want from a set of available applications. You name your unikernel, whatever you want. And then the first thing it's going to do is fetch all the sources that you need, including the application, but also the Unikraft sources as well. So it's downloading everything. And once it downloads all the sources, it's going to go ahead and start building. Now I'm going to skip ahead because this isn't, the build is pretty standard, so not so interesting. Once it's done, it's going to go ahead and run it immediately. So there it is. This is Nginx running on Unikraft. And to make sure it's actually working, we can curl it. There it is. We're going to use the address that it got printed, and you can get a Hello World HTML page. Okay. The other thing we're integrating into is Kubernetes. Here, there's another short video. So we're going to begin with a standard manifest YAML file. The only difference here is, of course, here we're using Unikraft, but the main difference here is that instead of using something like run-C, we're using run-U, which is a special unikernel environment that we put together that is pre-installed on this machine. With that, you can just apply the manifest. That means that the Unikraft unikernel was already created. So as far as Kubernetes is concerned, it thinks it's creating containers, but it's actually generating Unikraft unikernels underneath. And then you can use your kubectl commands completely unmodified. And you can see the log and see that Unikraft is actually running. running Nginx again, and you can curl it to see that it's working. Okay, and then if you go to the Kubernetes dashboard, this is again wholly unmodified, the standard dashboard. You can see that the Unikraft image is running and the log is there. Okay, and then we also have integration into Prometheus. For this, you can see a screen capture. This is a Unikraft in the kernel reporting on memory and network consumption by a Grafana dashboard. Okay, another quick thing I wanted to bring up is debugging. If you've heard of unikernels before, one of the weak points has been in the past that debugging has been a bit of a dark art and a little bit difficult in terms of tooling. In Unikraft, we're trying to fix that. So there's, again, an optional library that you can turn on called UK debug, and it has a logging and print system, assertions, trace points, but most importantly, it has a GDB server. So you can debug this as you would any sort of application or the Linux kernel. It's a full GDB server. There's a UK test library for unit testing. There's a UK store, which is a little bit similar to what a /proc system does on Linux. And there's also a performance profiling tool. We've also spent a lot of time in the past year or so improving the Unikraft documentation, so it should be much more easy to get around. And another thing that a lot of people focus on is security. If you've never heard of unikernels, they have some intrinsic security features. There's a compile time specialization strategy, which leads to a minimal trusted computing base. A lot of things are never ever deployed in the image, so it's sort of by default safer. The images are immutable and everything is off by default. So there's no unnecessary open ports, daemons. If SSHD is not needed, it's just not there. And just to test this, one thing we did is we pointed one of these security web-based analyzers at this AWS image that we put together. And you can see it gets all these A scores for security. There's also a security roadmap in terms of what features are implemented or being implemented, which ones are under review, and what's coming up if that is of interest. Unikraft, I perhaps didn't mention this, it's a Linux Foundation project. It's been around for about 4 years. If you want information, you can go to unikraft.org. There's all the information you could possibly want there. We also have a Unikraft Discord. I think we have a pretty friendly community. So if you have any questions at all or something you don't understand, or you have a project that you think Unikraft might be a good fit for, but you're not sure, please feel free to drop by and just ask a question. Another way to get involved is we regularly hold hackathons locally, but also remotely in different countries. So this is another way to get started. And if you really want to know a lot of the sort of low-level details of how Unikraft works, you can read this white paper from last year, which got the Best Paper Award. Okay, and here's a few more places to go. If you want more information, you can go to our GitHub page where all the code is. We have a tweet link there. And if you like us, please start us on GitHub. It really helps for visibility. So thanks a lot, and I really hope to see you online or on Unikraft Discord at some point.